Hi, I'm Josh Tipko, and I'm going to explain to you the differences between intermolecular forces and intramolecular forces. There are several different types of intramolecular forces, but I'm going to only talk about three of them. The first one is ionic bonding, the second one is covalent bonding, and the third one is metallic bonding. An ionic bond can be between several different substances. It can be between a metal and a nonmetal. For example, you can see here on the periodic table that metals are on the left, nonmetals are on the right, so it would be between something on the left and something on the right. It can be between a metal and a polyatomic anion, and that would be something like, remember that polyatomic ions are a charged ion composed of two or more atoms covalently bonded, or of a metal complex that can be considered as acting as a single unit. An example of that would be a chlorate or ClO3-. Could also be between two polyatomic ions or a polyatomic cation and a nonmetal anion. The first is ionic bonds. Ionic bonds is when electrons are transferred from one atom to the other. So metal cations, which are on the left, which are positive, are going to give an electron to the nonmetal anions, which are on the right. This is going to cause a transfer of electrons, which is going to basically make a bond. This will happen from stuff like sodium and chloride, which will make sodium chloride, aka salt. The second bond I'm going to talk about is covalent bonds. Covalent bonds is when two atoms need an electron, so they share the electron. As you can see here, the hydrogen has an electron, and the carbon needs 4 more electrons, and the hydrogen only needs 1. So they'll go, and the 4 hydrogens will share their electrons with the carbon, so they're all happy and have all their valence electrons filled. This bond is strong, but it is not quite as strong as an ionic bond. The last kind of intramolecular force I'm going to talk about is metallic bonds. These bonds are not near as important as most other bonds, and I'm not really talked about it, but I'll go over it briefly. A metallic bond is when metal cations and mobile electrons meet together and it forms a bond. This bond is not as strong as an ionic bond or a covalent bond, but it is still stronger than intermolecular bonds. Now I'm going to talk about intermolecular forces. Intermolecular forces are the forces between molecules which hold 2 or more molecules together. These are not nearly as strong as intramolecular forces. For example, with an H2O molecule, the intramolecular forces which hold the molecule together are 25 times stronger than the intermolecular forces which hold the water molecules to each other. One thing we need to quick go over is that molecular bond things are made only of nonmetals. So you can't really see the names here, but all the orange things are nonmetals. So it's everything and on the right, plus hydrogen, which is on the upper left. Because when it comes to separating metals and nonmetals, hydrogen is actually going to be placed next to the one on the right that has 18 above it, or helium. That's actually really important to know. Now the first type of intermolecular forces I'm going to talk about is dipole-dipole bonding. This is the attraction between oppositely charged regions of a polar molecule. Now it is essential for this that the molecule is polar, because if there's something that's more electronegative than another thing, and they have covalent bonding going on, the larger one is going to attract the electron more than the smaller one. So this is going to cause the larger one to become more negative because it has more electrons than the smaller one, or it's going to have this electron more often than the smaller one. So it's going to be more negative and the smaller one should be more positive. Now since you can see in the picture how these are different charges, the smaller one, which is positive, is going to attract to other similar molecules, where the other one is negative, and that's going to form a bond. This bond is not near as strong as covalent bonds, but it is still a bond, and it is one of the strongest intermolecular bonds. Now the second type of intermolecular force I'm going to talk about is hydrogen bonding. Hydrogen bonding is basically the same exact thing as dipole-dipole, except it uses nitrogen, oxygen, or fluoride atoms. These atoms, if you notice, are the farthest up and farthest to the right, except for the noble elements, and that's because these are the most electronegative. Now since they're so electronegative, they're going to attract the electrons so much more on their side, making it so much more polar than other atoms that they gave these a special group. These hydrogen bonds are the most powerful bonds of intermolecular forces, and these are very important because they hold water together, and water is used in everybody's everyday life. Now, the third intermolecular force I'm going to talk about is London dispersion forces, also called LDFs, or also called van der Waals. Now, this is when there's two atoms. They can be polar, they don't have to be polar, have electrons are constantly circling them that they're sharing. And since electrons are constantly circling, sometimes they're on one part of the atom and sometimes they're on the other part of the atom. Now, if they're all on one side, that's going to make the side that they're all on negative and the side that they're all not on positive. Now, if it's on the same with the other one, the positive one is going to link up with the negative one. This is going to cause it to have a bond. This bond is very weak though because the electrons are constantly changing and this is a very short bond. Now, because larger atoms have more electrons, the larger the atom, the larger the LDF forces.